For our final lesson in 7.3c is going to be solving real-world problems using the distributive property. And our goal for this lesson is to learn to write and then solve equations that require distribution based on real-world situations. So this lesson is primarily going to be just examples and how to go about solving them. So make sure that you have pencil and paper and ready to write down some examples. There is going to be a fair amount of writing since we have to write out some word problems, and I will expect to see the entire word problem written out for every single example. Let's go ahead and get started. For our first example, we have a family used a coupon at a restaurant to receive a $7.50 discount. That discount comes off the total price of their bill. They left an $8.90 tip, which was 20% of the reduced amount. How much was their bill before the discount? So that's what we're trying to figure out here. We're trying to figure out how much their bill was before the discount. So let's go ahead and define our variable. So for this problem, we're going to have x is going to be the bill amount before the discount. All right, so that's what our variable stands for in this problem. So let's kind of talk through about what's happening in this problem. Family gets a bill, they then give the waitress a coupon, and the waitress takes the bill back to the register, deducts $7.50 off the cost of the total bill, brings it back to the family. Family looks at the new amount and pays 20% or leaves a 20% of that new amount as their tip. That 20% amount of the reduced is going to be $8.90. So it's a lot to keep track of, but we have to think 20% of the reduced bill is going to be equal to $8.90. Let me say that again. 20% of the reduced bill is going to be equal to $8.90. So 20%. How would we write that as a decimal? 20% is going to be the same thing as 0.2. Okay, that's 20% of the reduced amount is going to equal 890, and 20% is represented by the decimal 0.2. Now the question is, how do we get to the reduced amount? Well, the original amount is represented by x. To get the reduced amount, we're going to take x minus 750. So we're going to go ahead and put parentheses x minus 750. Okay, so what I have written there represents 20%. Here's our 20% times the quantity, x, which is the amount of the bill before the discount, minus the amount that they were discounted. So 20% of the reduced amount. This is the reduced amount. Okay, 20% minus the 750 discount gets us the reduced bill. Now that 20% of the reduced amount is going to be equal, to $8.90. Okay? So 20% of the reduced amount is equal to $8.90. We know in dealing with our decimals that if we have a 0 as the last number of our decimal, we don't really need that 0. So 0.2 is equal to x minus 750, and that's going to be equal to 8.9. The hardest part about these is going to be writing the equation. Okay? We've done in 7.3b, we did equations like this. The hardest part about this is going to be actually writing the equation. So take some time and think about it. Again, 20% of the reduced amount equals $8.90. So 20% of the reduced amount equals $8.90. Well, here again, that's the reduced amount. Here, x minus 750, that's going to be our reduced amount. So we want to go ahead and get rid of our decimals in this problem. In order to do so, we're going to go ahead and multiply the entire thing by 10. The reason that we're multiplying by 10 is because we have our decimal terminates in the tens place here and in the tens place here. Notice here that we have a number that terminates in the hundredths place, and we know that we could get rid of that 0, but we're not too concerned about that because when we distribute, we don't distribute, or when we multiply by the entire equation, we're not going to multiply by what's inside the parentheses. We're only going to multiply the number out front and what's on the other side. So multiplying the entire equation by 10. On the left side, I have 10 times 0.2. 10 times 0.2 is going to move my decimal 2 place values to the right. I'm sorry, 1 place value to the right. So 10 times 0.2 is going to give me 2. And then I bring down my parentheses, x minus 750. And that's going to be equal to, on the right side, 10 times 8.9 gives me 89. All right, now this is a problem that I can go about and solve. I'm going to distribute my 2 now. So 2 times x, 2 times minus 750. So 2 times x is going to give me 2x. I bring down my minus sign. Now 2 times 750 gives me 15. So 2x equals 15. It's going to be equal to 89. Now I want to add 15 to both sides because my constant term is alone on the right. So add 15 to both sides. These cancel, and I get 2x is equal to 104. Finally, I'm going to divide both sides by 2, and I get x equals 52. All right, so x equals 52. Why do we care about x equals 52? Because that is the bill amount before their discount. So originally the waitress brings them a bill. It had a total of $52 on it, and the family says, you know, we have a coupon for $7.50 off. So the waitress goes back, takes the discount off, and then they give her a tip that is 20% of that reduced amount. But the original bill amount was for $52. All right, let's take a look at another one. For our second example, we have a company rents out moving vans that charges a flat rate of $25 per day plus 12 cents per mile for every mile over 100 miles driven. If the total bill is $29.46, how many miles were driven? So here's the scenario. You pay $25 to rent a moving van, and you get to drive up to and including 100 miles. If you drive over 100 miles, you have to pay 12 cents for every extra mile that you drive. So for instance, if you were to drive 101 miles, you would end up paying $25.12. Okay, $25 for the day plus the 1 mile over 100 that you drove. So let's take a look at how we can go about solving this problem. First thing that we have to figure out a variable, which is going to be, let's use m this time, which is going to be miles driven. All right, so solving this, we're going to use our variable m instead of x. Doesn't matter what variable you use when you're solving a word problem like this. If MyHRW tells you to use a specific variable, make sure you do so. In this case, we're going to use m to represent the total number of miles driven. Now, for writing this equation, first part should be the easiest part. We're going to start off with 25 plus. Okay? It's written right there. $25 per day plus. Okay? So we don't know exactly how many miles she's driven, but we know that she gets charged $25 for her 1 day of renting the van. Now, we know that her total is going to be $29.46. So I'm going to skip around a little bit while writing this equation. So her total is going to be $29.46. So $25 to rent the van up to 100 miles. But her bill is more than $25, so that tells us that she drove more than 100 miles. So if you get to the end and your value for m is less than 100, that does not make sense. That is not an answer that makes sense because we know that if the total that she pays is greater than the amount of the daily flat rate that she must have driven over 100 miles. Now the question is, how do we figure out exactly what to put there and then to solve for the number of miles that she drove? We know we're multiplying 0.12 by the number of miles, but it's not for all the miles, it's just for the miles over 100. So we're going to have 0.12 multiplied by the number of miles she drove that was more than 100. So again, 0.12 times the number of miles over 100. Well, miles is represented by m, the miles over 100. So if we drive 101 miles, we're only going to be charged for one of those miles. So think about that. Miles driven is 101, but we're only being charged for one. We only have to pay 12 cents for one of those miles. So we're going to take the number of miles that were driven and subtract 100 from that. Oops. There we go. So when I was working on this problem, to be honest, I wasn't sure exactly what this expression here should be. I thought about it a little bit, and finally I was like, you know what, I don't know if it's supposed to be x minus 100 or if it's supposed to be x plus 100. So I thought that x minus 100 sounded better, and so I worked through the problem, and my answer made sense. That's why I told you earlier that we know that based on her total, she must drive a total of 100 miles. Or I should say that it needs to be at least 100 miles. So when we try x minus 100, if we get an answer where the value for m is less than 100, that is not an answer that makes sense. So our equation, let's try 25 plus 0.12 times the quantity x minus 100 is equal to 2946. In order to get rid of our decimals, we see that we terminate in the hundredths place here and the hundredths place here. So putting brackets around the entire thing. I think my HRW might call those square parentheses. They're called brackets. If you want to call them square parentheses, that's fine, but they're called brackets. We're going to take the entire equation and multiply it by 100. So first, 100 times 25 gives us 2,500. Bring down our plus sign. 100 times 0.12 is going to give us 12, and bring down our parentheses. Remember, we do not distribute our 100 into the parentheses. Bring down our equal sign, doing our best to keep things aligned. And then finally, 100 times 2946 is going to give us 2,946. All right, so now we're ready to go ahead and start solving this problem. First step is to distribute. So I'm going to bring down my 2,500, bring down my plus sign, and now when I distribute my 12, I get 12x, bring down my minus sign, and I get 1,200, bring down my equal sign, and that's going to be equal to 2946. Now I'm going to go ahead and combine like terms. Have this 2,500 here, this minus 1,200 here. When I combine those, I get 12x plus 1,300 is equal to 2946. Now I'm going to subtract 1,300 from both sides. And I get a final answer of, not a final answer, my next step is 12x is equal to 1646, I mean. So, next, divide both sides by 12. And we get x is equal to, feel free to use a calculator here, I did. And we get 137. I think we could leave it at that because I think the problem said to round it to the nearest whole mile. So x is equal to 137 miles. We said earlier up here that m is going to be miles driven, but I forgot to use m for the entire problem. So I'm going to come back up here, change this to x because I would use x instead of using m like I meant to. So x is our miles driven, so x is going to be 137 miles that they drove the van for. All right? I know we're getting about that time, but I still want to take a look at one more problem that will be hopefully beneficial to you as you go through and work through your homework. For our final example, we have a chemist mixed X milliliters, or mLs, of 35% acid solution with some amount of 10% acid solution to produce 100 milliliters of a 33% acid solution. Use this information below to complete the table and answer the questions below. So let me kind of walk through what we have going on here. I want you to picture in your mind two beakers or two graduated cylinders or something like that, and we don't know how much solution or how much liquid is in the two beakers. But we know that one of the beakers has a 35% acid solution, and we know that the other beaker has a 10% acid solution. And we also know that the chemist mixes those two solutions together to result in 100 milliliters of a 33% acid solution. So eventually what we're going to try and figure out is how much of each solution did he start with, or did she start with? How much of the 35% acid solution did they have, and how much of the 10% acid solution did they start with? So that's our goal with this problem, to figure those things out. And you're going to have a problem like this in your homework, so that's why I wanted to go through this with you. So let's go ahead and fill in a table first. All right, so here's our table. Take a moment, pause the video, and copy it down. So when you guys work on this problem for your homework, you'll see that you'll be given some information. For example, we're told that the milliliters of 35% solution is going to be X. We're told that there's going to be 100 milliliters of the 33% mixture, but that's about it. Everything else in the table we have to fill in ourselves. So for the 35% solution, we want to write the percent of acid as a decimal. So for that, we just come over here to the percent. So 35% written as a decimal is going to give us 0.35. All right, 35% as a decimal is 0.35. Now over here on the right, to find the milliliters of acid, we're just going to multiply these two things together. So we're already given the X here, and so now we just have to show that we're multiplying the 0.35 by X by filling in 0.35 here. Okay? So again, took these two things, multiplied them together to get this. Now for our 10% solution, we're going to be doing the same thing. Now notice, up here, we're given X, and we have an X over here. Down here, we have a 100 minus X. Over here, we have a 10 minus X. So to find the 10% solution, we're going to have 100 minus X. And then to write the decimal, the percent of acid as a decimal, we go to the percent, which is 0.10, or is 10%, and we rewrite that as 0.10. And so our milliliters of acid is going to be 0.10 times the quantity 10 minus X. Now, final row, we have our mixture row right here. We know that altogether that there's 100 milliliters of the solution, and we know that the percent of acid in the solution is going to be 33%. So for our decimal, it was going to be 0.33. Now to find our milliliters of acid right here, well, we know that if it's 100 milliliters of solution, which is what we have right here, and the percent of acid as a decimal, we're going to multiply these two together. Just like we multiplied these two together to get this, we multiplied these two together to get this. So we're going to take 100 multiplied by 0.33, and that is going to give us 33. So there's our table all filled out. Now, in addition to the table, there's some additional questions that we're going to have to answer. So let's say that we're trying to figure out an equation that we could write to help us find the original amount of the milliliters of solution for the 35% solution and the milliliters of the 10% solution that we started with. So again, going back to the beginning, we have a chemist who has two beakers or two graduated cylinders. There's a certain amount of 35% solution. There's a certain amount of 10% solution. He takes those two solutions and he combines them together into one larger beaker to form a mixture that is 33% acid, and there's 100% of that, or 100 milliliters of that solution. So we're trying to figure out how much 35% solution did he start with, or she start with, and how much 10% solution did they start with. So to write our equation, we're going to take the milliliters of acid in the 35% solution plus the millimeters of acid in the 10% solution, which will equal the milliliters of acid in the mixture. So essentially what that means, we're going to take this value plus this value to equal this value, and that will give us our equation. So writing it all out, we're going to start with 0.35x, which we got from right here. We're going to add to that 0.10 times 100 minus x is going to be equal to 33. So again, all I did, I took this value plus this value to equal this value. All right, I'm taking the amount of acid in the first solution plus the amount of acid in the second solution to equal the total amount of acid in the third solution. Now, solving this, we see that our decimal terminates in the hundredths place here and in the hundredths place here. So we need to multiply our entire equation by 100 to get rid of our decimals. So I'm going to put my brackets around the entire thing, multiply by 100. When I multiply on the left, the 0.35x, it's going to give me 35x. Bring down my plus sign. Next, when I distribute to my second term, I'm going to get 10 times the quantity 100 minus x. And that's going to equal 33 times 100 is going to be 3,300. So there's my equation after I get rid of all my decimals. Let's go ahead and solve that. First thing I want to do, I want to distribute this 10 to get rid of my parentheses. So I'm going to bring down the 35x, bring down my plus sign. 10 times 100 is going to give me 1,000. Bring down my minus sign, minus 10x. That's going to equal to 3,300. Next, I'm going to combine my like terms. I have a 35 and a minus 10x here. I have a 1,000 here, and on the right side there's no terms I can combine. So my like terms on the left are going to be 35x and minus 10x. So when I combine those, I'm going to get 25x plus 1,000 is equal to 3,300. So again, to get this 25, I just took 35 minus 10. My next step, I'm going to move my my constant terms over to the right side. So we subtract 1,000. These will cancel, leaving me 25x is equal to 2,300. And my last and final step is going to be to divide both sides by 25. And we get x is equal to 92. So 92 what? Why do we care about what x is? Well, if we go back up to our table, we remember that x is the milliliters of solution of the 35% solution that we have. So that means that the chemist used 92 milliliters of a 35% solution. Okay? So 92 mLs of 35% solution. And then in order to figure out the percent of the amount used of the 10% solution, we would take 100 minus our value for x. We see that here. 100 minus x is going to give us 8. So we have 8 milliliters of 10% solution. A lot of work for that problem. But none of that work is beyond our scope of ability. It's just a matter of taking it step by step, thinking through what we're actually doing here. Again, it's a chemist taking beaker 1 and beaker 2, pouring them together into beaker 3 to form 100 milliliters of a 33% acid solution. All right? So one of the beakers that he pours has 92 milliliters of 35% solution, and the other beaker he pours has 8 milliliters of a 10% solution. Okay, now I'm not sure what you would do with a solution like that, to be honest with you. You could ask Ms. Traziak about that in class maybe. But if you wanted to end up with a 33% solution and you only had a 35% and a 10%, that's how you could go about making sure that you have a 10% or a 33% solution. So a lot of word problems in our lesson today. We went through 3 examples. It took us a while to get through those 3 examples, but hopefully they will help you out in the homework. So hopefully at this point you're able to write and solve equations requiring distribution from real-world situations. Any questions or concerns, go ahead and write those down, and we'll go over those together in class.